Assalamualaikum to Sir Saiful and our fellow classmates. So today our group will be presenting our STA108 assignment titled Analyzing the Relationship of Waist Circumference on BMI. So this is our group members.
This slide contains introduction, methodology, result and interpretation, and conclusion. Background of study. BMI and waist circumference relationship gaining attention in health discussion. As societies undergo shift in lifestyle and dietary patterns, the prevalence of health-related concerns had heightened, making it imperative to investigate the intricate relationship between BMI and waist circumference. BMI defined as overall body composition, and waist circumference focus on abdominal fat distribution. In addition, BMI offers broad insight into body fat, and waist circumference provides specific data on abdominal fat. Research has suggested a possible connection between abdominal obesity and certain health issues, such as cardiovascular illness and metabolic disorder. However, a comprehensive and nuanced exploration of the relationship between BMI and waist circumference remains a critical research gap. This study was carried out to investigate the impact of waist circumference on BMI. The data source was obtained from www.statcrunch.com. The data for this study was taken from 30 different individuals. Objective of study. Firstly, to determine the relationship between BMI and waist circumference. Second, to describe the numerical measure for BMI and waist circumference. And lastly, to find the correlation and skewness of the data between BMI and waist circumference. Significance of study. This study has great importance in adding to the changing field of body composition assessment. The research intends to enhance health assessment methodologies by examining the influence of waist circumference on BMI. This will provide detailed insight into the complex connection between central adiposity and overall body fatness. The discoveries could have significant consequences for public health, shaping the creation of more specific and individualized health solutions. Furthermore, this study enhanced precision in health evaluation. Specific insight into how waist circumference affects BMI in broader health context. Limitation of study. Data gathering is a limitation of this study. The information was taken from a database that is accessible online, so this is considered secondary data. In addition, the question session may be held to establish the data accuracy. Next, the data may differ in the aim of the research to meet our objective because another researcher discovered the data.
Next, moving on Chapter 2 Methodology. For the data description, number 1, variable for waist circumference is independent variable. The type of variable is quantitative. Quantitative is a continuous variable that can counted or measured. And the level of measurement for waist circumference is interval data. It is classified as quantitative data, and it is the most effective scale of measurement. Next, variable for BMI is dependent variable. The type of variable for BMI is quantitative. It is continuous variable that can counted or measured. And lastly, level of measurement for BMI is interval data. It is classified as quantitative data, and it is the most effective scale of measurement. Next, moving on to graphical technique. There are two graphical techniques that we use, which are histogram and box and whisker plot. Firstly, for the histogram, variable for waist circumference is X, meanwhile variable Y is body mass index, BMI. And secondly, box and whisker plot. Variable X is waist circumference and variable Y is body mass index, BMI.
So moving on to my part, which is 2.3 numerical technique. Numerical technique is a method that uses calculation approach in order to determine the information based on the data we have. So here you can see we have 5 numerical technique, which is mean, mode, median, variance, and also standard deviation. So for the first one is mean. Refers to the average set of data used in a statistical theory. It was included among the simple measure of central tendency. For the second one is mode. In statistics, refers to the number in a set of numbers that appears the most often. The mode is different from the mean, which is the average of the numbers in a set, and the median, which is the midpoint of a set. So for the third one is median. Median refers to the metric used in statistics that represents the middle value of a set of numbers when arranged in ascending order or descending order. In short, we can say median is the middle data point in the list. Step 2, calculate it. Arrange the data in an ascending order. Second, find the position of the median in the collection of data. Last one is find the value of median with appropriate measurement and calculation. So next is variance. In statistics, is a measure of how data points differ from the mean. It is the expected value of the squared variation of a random variable from its mean value. For the last one, which is standard deviation. In statistics, standard deviation is a measure of the amount of variation or dispersion of a set of data from its mean. It is a summary statistic that tells you how much the data deviates from the mean.
So now we're moving on to 3.1, which is data presentation. So this is the table represent 30% BMI level in West Circumference. So this table contains an ungrouped data. Moving on to 3.2, which is descriptive statistic analysis. For 3.2.1, which is histogram graph, and this is our histogram graph for BMI and frequency. This graph represents a sample size of 30%. The highest BMI is 30.40, while the lowest being 13.50. The mode for this variable is 16.90, and it's skewed to the right because the line of the distribution is more longer to the right side. Next is histogram graph of West and frequency. This histogram represents 30% West circumference. The highest West circumference is 36, while the lowest West circumference is 22. The mode for this variable is 25, and the skewness is to the right. Next, here we have 3.2.2, which is box and whisker plot. So on the left side is the box and whisker plot for West, and on the right side is for BMI. So from the box plot, we got that the Q1 is 25.75, and for the Q3 is 31. And from that information, we got that the interquartile range is 5.25. And for the BMI box and whisker plot, Q1 we have 17.40, and Q3 we have 22.05. And from that information, the interquartile range is 4.65. And lastly, for 3.2.3, we have scatter plot. And this is our scatter plot for our data. And at the y-axis, we have BMI. Meanwhile, at the x-axis, we have waist. So each of the dot here is represent the data. And from this scatter plot, we know that these two variables have positive correlation.
Next, relation and regression analysis.
The value of R equals to 0.906 indicates a moderate correlation between waist circumference and body mass index BMI. A positive linear relationship observed, affirming that higher BMI correlates with higher waist circumference. Regression coefficient of determination R squared equals to 0.822 means that 82.2% of the variability of the waist circumference can be explained by the body mass index BMI. The remaining 17.8% is unexplained variability of the body mass index BMI. Other than that, the value of R equals to 0.906 suggests a moderate correlation relationship between the waist circumference and the body mass index BMI. It proved that the higher the waist circumference, the higher the body mass index BMI. The linear regression equation is y equals to negative 7.820 plus 0.983x. The value of B equals to 0.983 means that for every increase in the waist circumference, the body mass index BMI will increase by 0.983. Fitting a straight line. When we interpret the slope, if the waist circumference increases by 1 rate, the body mass index BMI predicted will increase by 0.983. When we interpret the intercept, if the waist circumference cases are 0, the body mass index BMI predicted is negative 7.820. Conclusion. From this study, we know that the variable is BMI and waist circumference that measure in inches. Central tendency measure. The waist circumference mean equals to 28.267 inches. The mode is 25 inches and the median is 27.750 inches. The BMI mean is equals to 19.977 and the mode is 16.9. The median is 19.200. Interquartile ranges, waist circumference is equals to 14 and BMI is equals to 16.9. The dispersion measure. The waist circumference variance equals to 13.116 inches. The standard deviation equals to 3.6212 inches. The BMI variance equals to 15.438 and the standard deviation equals to 3.9291. Data distribution. Both BMI and waist circumference data distribution are positively skewed. Visualization tools recommend that using a histogram, scatter plot, box, and whisker. Correlation value of 0.906 indicates a moderate association between BMI and waist circumference. The regression formula is negative 7.820 plus 0.983x. B equals to 0.983 rise in BMI with an increase in waist circumference. The study effectively meets its objective. Thank you!